Alright, this is section 5.7 part 2. Now we're trying to find an inverse of a polynomial function by restricting the domain. So if a function is not one-to-one, it cannot have an inverse. But if we restrict the domain of the function so that it is or becomes one-to-one, thus creating a new function, this new function will have an inverse. Okay, so finding the inverse of a polynomial function by restricting the domain. First, restrict the domain by determining a domain on which the original function is one-to-one. And then the rest of the steps are the same steps that we follow when finding an inverse. So let's look at this right here. Restrict the domain of x minus 2, that whole thing squared, minus 3, then find its inverse. Now, we know that the parent function to this is x squared, which looks like a parabola, or it is called a parabola. It starts here at the origin and does something like this. But when you have a negative 2, that means it went 2 units to the right, like this. And this negative 3 means it went 3 units down. So it's starting down here. And let me move this function. So we have something like this. Now we know that this is not a one-to-one function because it does not pass the horizontal line test. It crosses more than once. Okay, but we can restrict the domain. Now we know that right here, this is the point 2, negative 3. Now if I restrict it to where x is bigger than 2, so say x is greater than or equal to 2, then that gets rid of this little piece right here, and now it is a one-to-one function because it passes the horizontal line test. So we're going to say that the domain of the original function is going to be, and let me get rid of this right here. So the domain will be x greater than or equal to 2. So we can say it goes from 2 to positive infinity. So from 2 to positive infinity. Okay, now we can find the inverse of this. So we can get rid of all of this right here. Okay, so f of x is equal to, and I'm going to replace that with y. I'm going to go ahead and replace that with y. So y is equal to x minus 2 squared minus 3. Switch the x and the y. I'm going to add 3 to both sides. So y minus 2 squared. Now I need to square root both sides. I put that plus or minus sign in front of it. So plus or minus the square root of x plus 3 is equal to y minus 2. Add 2 to both sides. So then we have 2 plus or minus the square root of x plus 3 equals y. And last thing to do is to change that y, which I don't think I did in the other video before this one. But change that y to the inverse of x notation. Now, what we have here is a plus or minus y, and we've restricted the domain to be x greater than or equal to 2. Okay, so what we need to do is we need to take the positive version of this. So 2 plus the square root of x plus 3 is equal to the inverse function. Okay, now let's look at this function right here. We know that the parent function here is the square root of x, which starts at 0 and does this number. But since I've got minus 4, that means it's scooted to the right by 4 units. So really what I have is this right here. Okay, and it keeps increasing. Now when you're working with radicals, what you need to do is find the range of this function. So the range of this function would start at 0 and go up to infinity. Remember, range is just a code word for all the y values. And notice it starts here, right here, and goes up. So that's at the x-axis, and at the x-axis we know that y is 0. Okay, and let me write that just a little bit bigger. So at the x-axis, we know at that point y is equal to 0. So it starts there and then it keeps going up for y, so that's up to positive infinity. And if we need to restrict that, we can, but it looks like this is already a one-to-one function. Okay, so what we need to do to find the inverse is I'm going to change this to y, switch my x and my y values, and then solve for y. So I need to square both sides. So x squared is equal to y minus 4. Add 4 to both sides. So x squared plus 4 equals y. So the inverse function of x is equal to x squared plus 4. Okay, now we know that this right here is a parabola that is scooted down 1, 2, 3, 4 units. Okay, now that is not going to be, we had 1 scooted over 4. That's not going to be the inverse of the square root of x minus 4. So what we need to do is take the range of the original function and make it the domain of the inverse function. So we need a comma, and then this over here, we could write that y is greater than or equal to 0. Down here, this is for the original function f of x. For the inverse function, we're going to say x is greater than or equal to 0. Because remember, when you go from the original function to the inverse, your x's and your y's switch. So this would be your final answer right here. Now let's look at this one right here. Find the domain on which f of x is equal to negative 1 over x squared is 1-to-1 and non-decreasing. So if we graph this, we know that y equal to 1 over x squared looks something like this. But since I got the negative in front of it, it flips it over the x-axis. Move that up. So now it looks something like this. Okay? Now it says we want this to be non-decreasing. Okay, find the domain on which this is 1-to-1 and non-decreasing. Okay, so if we get rid of this right here, and let me show you why, because you're starting here and you're going down, so this would be decreasing. You're starting over here and you're going up, this would be increasing. So if I get rid of this part over here, well, the number 1, hey, it's 1-to-1 because it passes the horizontal line test. And number 2, it is non-decreasing, so it's well, not necessarily increasing, but it could be constant, but it's not decreasing function. Okay, so domain, that's talking about the x values. Okay, so it looks like it gets close to 0 for x, but doesn't touch it, so 0. And then it keeps going this direction, so it goes to positive infinity. So this would be the domain for this function right here, to where it is 1-to-1 and is non-decreasing.